So, good afternoon, students. So, today we'll discuss about the continuous distribution. So, in the first unit, we'll see about the rectangular distribution. So, what are the objectives of the rectangular distribution is? One second. Is so after reading, like after completing this unit, we'll get to know about we will able to do the definition of the rectangular distribution and finding the moments of the distribution and skewness and the kurtosis of the distribution and deriving the moment generating functions. We will know like call it as MGF anamata. So MGF. So let's come to the rectangular distribution. It is also known as the uniform distribution, rectangular distribution, or else uniform distribution. A random variable x is said to be continuous distribution over an interval a comma b if its probability density function is k, say over the entire range x. So they are saying we are taking a random variable x and we are saying it is said to be a continuous distribution over the interval is a comma b. So and PDF. What do you mean by PDF? PDF is the probability density function. We are saying it as K. So the thing will be, so f of x is equals to K. F of x is equals to K. Eppudu K. If K is having the interval of A less than X or less than B. So the X should be, the A should be less than A. So X should be greater than A and less than B. So otherwise, if this condition does not work, then the answer will be 0. Otherwise, if this condition does not work, the answer will be f of x will be 0. So the total probability, we know total probability is always equals to unity. Means definitely the probability will be equals to 1. So we are equating this function to the 1. So we are doing the integration of a to b f of x into dx is equals to 1. So we know f of x means what? K. We are taking it as k because uh, we are having the interval of a comma b, a to b. Then we are taking definitely f of x is equals to k. So if you are taking f of x is equals to k, it will become a of b, k into dx is equals to 1. The k will come outside. K into a, integration of a to b into 1 into dx is equals to 1. So integration of 1 will be definitely x. So k into x into interval b a equals to 1. We know in the place of x we'll substitute the interval. It means k into b minus a is equals to 1. So what will be the k value? So k is equals to 1 by b minus a. The k value will be 1 by k minus b minus a. So this is the k value. So see the same answer. So k is equals to 1 by b minus a. So what is the condition now? So what is the, we are in the previous we have seen that f of x is equals to k, k if the condition is a less than b, x less than b and 0 otherwise. So what is the value of k? We are deriving the value of k as 1 by b minus a. So what will it will be? So f of x is equals to, in the place of k, we will substitute 1 by b minus a. So the condition will be a less than x less than b, or else otherwise it will be 0. So these are the condition we will derive it. So here they are saying here a and b are two parameters of the uniform distribution. They are saying what are the parameters of the uniform distribution? The two a comma b are the two parameters we are using for the uniform distribution. So what they are saying, x follows the uniform distribution with the parameters of a comma b, then its probability density function. What is the probability density function? F of x is equals to 1 by b minus a if the condition is a less than x less than b, otherwise it is 0. So we are taking the probability density function. So what happens? There are two things we can conclude from this probability density function. One is the f of x. we are deriving this f of x, right? It should be, must be greater than or equals to 0. So it should be 1, 2 or so on. So it must be greater than 0. And second condition will be integration of minus infinity to infinity of f of x. If we do integration for the f of x with the interval minus infinity to infinity, it should be definite into dx is equals to, definitely should be unity, means it should be equals to 1. So how it is getting 1, we will also discuss that. So we are taking integration of a to b f of x into dx is equals to into dx is equals to integration of a to b by what is the k value? B minus a into dx. So the 1 by b minus a will comes outside, right? So it will be integration a to b 1 by b minus a into x of b minus a. Sorry. So it will become a to b by 1 by b minus a into dx. So this will come outside. So 1 by b minus a is equals to integration of a to b into x into dx and matter. So 1, it can be 1. So in the place of 1, we can substitute as x. So 1 by b minus a x of b a to b. So it will become 1 by b minus a, b minus a. So what will happen? B minus a, b minus a, 1. Cancel. It can be cancelled. So the answer will be 1. So that's why they are saying f of x is a probability density function. PDF. It is a probability density function. So this is about the uniform distribution. So the distribution function of the uniform distribution also we'll see now. So the distribution function of uniform distribution is, can be defined as, they are defining it as f of x equals to probability of capital X less than or greater than small x. So how they are defining this, we'll see now. So we are taking integration minus infinity to infinity f of x into dx. So what is f of x value? Before only we saw, like in the place of infinity, infinity, we'll take it as a. We know the a value. So a x f of x into dx. So what is f of x value? We already derived f of x value is equals to 1 by b minus a into d. 1 by b minus a into dx. So 1 by b minus a. So we are taking the 1 minus b, 1 by b minus a into 1 by b minus a outside. So it will become 1 by b minus a into x minus a. So in the place of x, we'll substitute x as well as a. So it will become 1 by b minus a into x minus a. So definitely it will be x minus a by b by a. So what is the density function here? F of x is equals to 0. When it will be 0? If the x is minus infinity to a. If it lies between minus infinity to a. Or else x minus a by b minus a, when it will be a less than or equals to x, less than or equals to b. And 1 if b less than x and less than or equals to infinity. So these are the 3 conditions we will require. So if we see, since f of x is not continuous, so it is not continuous, right? It is a density function, probability function. It is not continuous. So if at x is equals to a and x is equals to b, we can say it is not continuous. It is not differentiated at this point. So d of x of, we are doing the differentiation. D of x, dou by dou x into f of x is equals to 1 by b minus a not equals to 0. They are saying that only it is not continuous. So then the conditions will be like, in this, they are taking 2 graphs, figure 1 and figure 2. In f of x side, we can say 1 by b minus a. And this is a curve. This is a graph showing x is equals to a and x is equals to b. So from the last rectangular or uniform variate, in the parameters of minus a comma a, we can derive that f of x is equals to 1 by 2a. 1 by 2a. If the condition is x is having the intervals of minus a and a. So the x should be greater than minus a and should be less than a. So otherwise, if this condition is not work out, then we can say it is f of x is equal to 0. So this is the distribution thing. Next, coming to the movements of the rectangular distance. How we can calculate the movements of the this rectangular distribution, we'll see now. So the non-central movements or the movements about origin is given by. So we are doing just remember, we are doing just 1 second. Just we are doing non-central movements. Mu r1 equals to expectation of x r. We are taking mu r dash equals of x power r. So it can be expectation of x power r means integration of minus infinity to infinity x power r f of x into dx. F of x into dx. So it will be what? So integration minus infinity to infinity x power r f of x into dx. So where f of x is a PDF of corresponding distribution, we can say mu r dash is equals to integration a to b x power r. In the place of f of x, we are substituting the 1 by b minus a into dx. It means the x is having the intervals of a comma b. The x is having the intervals of a comma b. Next. So we are taking the 1 by b minus a outside. So it will become 1 by b minus a into x r plus 1 by r plus 1 interval of b a. So in the place of x, we will substitute b as well as a also. It will become 1 by b minus a. In the place of r x, we are substituting the b as well as a. So it will become b x plus a minus a, sorry, r plus a, b r plus a minus a r plus 1 by r plus 1. So this is the thing we are getting here. In the start, we can see that only. So in particular, we are substituting 1. So what we are doing in the place of r, we are substituting 1. What will happen in the mu r1, right? In the place of mu r1, we are substituting r equals to 1. Then it will be mu 1 equals to 1 by b minus a. In the place of r also, we are substituting 1, right? So it will be b r plus 1. 1 plus 1. It is b square minus r plus 1. A r plus 1. It will be a square by 1 plus 1. 2. So it will become 1 by b minus a into b square minus a square. It can be written as a plus b into a minus b. So a plus b into a minus b. So it is b square minus a square, right? So b plus a into b minus a by 2. B minus b can be cancelled. So it will be b plus a or a plus b by 2. So what is the mean of mean here? So we can say mean mu 1 dash is equals to b plus a by 2. So this is the first non-central movement. So coming to the second non-central movement, we'll substitute r is equals to 2. It is very simple. So you can do so on. So if you know how to do the first one. So after getting the first one, we'll consider it as mean. So for the second one, Okay. For the second one, we will keep r is equals to 2 in the place of this star equation. So what will it happen? Mu r 2 dash is equals to 1 by b minus a into b r plus a. So what will it will happen? So b 2 plus 1 means b3 b cube minus a cube by 3. So if we can return b cube minus a cube as b minus a into b square plus a square plus ab. So it will be ab plus a smaller by. So already we are having a b minus a into 3 also. So what will it happens? B minus a, b minus a cancel. So the equation will be b square plus a square plus ab by 3. So this is the equation we are getting by if we are keeping the r is equals to 2. So what it will happen if we are keeping the r is equals to c? So r power 4 minus a power 4. So it will become a like because b power 3 r plus 1, right? So r is 3. So 3 plus 1 b power 4 minus a power 4 by b minus a into 4. So we can write b power 4 minus a power 4 as b square plus a square into b plus a into b minus a. So that b minus a down, b minus a will be cancelled. So we'll get b square plus a square into b plus a by 4. So this is the third one. So for the fourth one also you'll get the same value. These are all what we are doing now. We are doing the non-central movements. Next comes to the central movements. How to do central movements? We'll see. So the central movements formula will be, we are already done with the mu square, mu 2 dash. So if you want mu 2 dash, it will be after mu 2. Then it will be mu 2 dash minus mu 1 dash from the non-central one. So mu 2, if you want mu 2, it means in the central movements, it will be calculated as what is mu 2 dash? Mu 2 dash is b square plus a square plus ab is the by 3 is the mu 2 dash minus mu 1 dash. What is mu 1 dash? Mu 1 dash is here. So b plus a. So this will be actually mu 1 dash whole square, actually mu 1 dash square, that is. So it will become as b plus a by 2 whole square. So they are taking as b plus a whole square by 4. B plus a whole square by 4. So what will it will be done. So definitely we know for this we have to do the LCM. So the LCM will be 12. So b square plus a square plus ab into 4 minus b square plus a square. We will also know that it is a square plus b square plus 2ab. So for this 4b square plus 4a square plus 4ab minus 3a square minus 3b square plus 6ab by 12. So we will simplify it as see, a minus b. We can directly write it as, actually that is a formula also, but we can do like that also if you are not getting. So b minus a by 12, b minus a minus b whole square by 12. So what is this central moment we are finding? Mu 2. Mu 2 means it is defined as variance. So variance of the rectangular distribution is a minus b whole square by 12. So next we will discuss about the central moments for the uniform distance. So actually this what we like concluded. So these are the non-central movements. So now coming to the central movements, the formula will be mu r is equals to expectation of x minus expectation of x whole power r. It should be anything. So expectation of x minus, in the place of expectation of x, so in the place of expectation of x, we are writing it as b plus a by 2, because it is already derived in the non-sentence, and before only we concluded that f of x, expectation of x, f of x is equals to b by a by 2. So expectation of x, we are concluding it as integration of a to b x minus b plus a by b plus a by 2 whole power r f of x into dx. So there, why we are taking means this is a formula. Expectation of x is equals to integration of a to b x into f of x into dx. So from this we can conclude what is f of x. F of x is 1 by b minus a. So what are the things you have to know first? So f of x is equals to 1 by b minus a, and as well as expectation of x. What is the expectation of mean value? It is a plus b by 2. In the non-central one, we already find out expectation of x. This is also known as mean also. Okay. So we are substituting all the values here. So we are taking 1 by b minus a outside. So it will become 1 by b minus a integration of a to b x minus b plus a by 2 whole power r into dx. Let us use the transformation. How we are using the transformation? We are concluding y is equals to x minus b plus a by 2. So this thing we are concluding it as y. Whole thing as y. So if the whole thing is y, if we are differentiating, it will become d of x, d of y into d of x. Yeah. If you are keeping x is equals to a, so what it will be happens in the place of x, we are substituting the a value. Y is equals to a minus b plus a by 2. So a minus means what it will happen. So y is equals to LCM. If you do a minus b minus a. So it will become minus b means b plus a by 2. So we are taking the minus common here because we want b minus a. So if we are taking the minus common, it will become minus b becomes the plus b, as well as plus a becomes the minus a by 2. So it will become minus of b minus a by 2. So we will conclude as b minus a equals to c. So the answer will be y is equals to minus c. So if you are substituting the x is equals to a, this is the equation we are getting. If you are substituting the x is equals to b, what will happen means, so in the place of x, we will substitute the b. So it will become y equals to we'll know definitely for this answer also it will come like this only. In the place of minus, we'll get the plus. So we'll conclude if x is equals to b, it will conclude as y is equals to c. We'll say it as c. It is not concluded. We are saying it as c. So now coming to the central moments, mu r. Mu r is equals to 1 by b minus a integration of minus c. Why we are taking minus c? So we are taking the y. Y means ab. That one, this one we are taking x is equals to a. So it will become y power a into dy. So if the r values, we are taking the r values as 1, 3, 5. If it is odd values, then we can conclude it as, one second. Yes, see. So if the R values are R1, R3, R5, R7, so on, their R values are odd numbers, then we can conclude these are the equals to 0. They will definitely equals to the 0. And one more thing we can conclude that if the R values are even 2 comma 4 comma 6 comma or anything, any even number, we can conclude it as what? We can conclude it as different values. So we'll see with the example. So in this we are substituting 1 by b, integration of minus c to y into dx dy. It will become different we are doing. For the minus c we are doing the integration one time, and for the c also we are doing the integration one time. For taking the upper interval as 0 for the minus c, as well as the uh, and lower interval for the c as 0. So this y will become the y square by, because it is y1, right? What is the formula of x power n something? So it will be x power n plus 1 by x plus n plus 1, right? So it will become y square by 2, and interval of 0 minus 3 for again c and 0 also it will be the same. So we can get 0 only. So for the, if you are taking the mu is equals to 3 as like mu 3 or mu 5, if you are taking r is equals to 3 or 5, definitely for sure you get the value of the equation as 0. So this is only workoutable for the odd numbers only. If you are taking the even numbers, what will happen? We'll see. So in the place of this, we are taking, what is the formula of this? So mu r is equals to b minus a by r plus 1 of r 2 power r. For separate differentiation. So 2 power r. So in this equation, we are substituting the r is equals to 2. If you are substituting the r is equals to 2, mu 2 is equals to b minus a whole square by 2 plus 1 into 1 by 2 square. We'll get 1 by 2 square. So what it will become? B minus a whole square by 3 into 1 by 1, 2 square is 4. So it will become b minus a whole square by 12. So what is mu 2 value? B minus a whole square by 12. So this is the value. So see. So b minus a whole square by 12. So for the fourth one, if you are taking r is equals to 4, so it will become mu 4 is equals to b minus a whole power 4 by 4 plus 1 into 1 by 2 power 4. 2 power 4. So this is the for fourth one. We'll get it as b minus a whole power 4, because we are taking r is equals to 4, right? So what we are doing for the fourth one, r is equals to 4, we can conclude it as b minus a whole power 4 by 80. If you are taking for 6, it will be b minus a whole power 6 by something value. If you are doing. So you can do very easily this thing. So for uniform distribution, the skewness and the kurtosis as are follows. So what will be the skewness as well as the kurtosis? We'll see for the uniform distribution or else for the rectangular distribution. So the skewness will be defined as B1, beta 1 is equal to, we can call it as beta 1, mu 3 square by mu 2 cube equals to 0. So what is mu 3? So it will be definitely equals to 0. So the beta 1 is equals to 0. So for this, it is definitely for the uniform distribution. You need to remember that the skewness is symmetric because it is equal to 0. It is symmetric for the uniform distribution. So the for the cutoffs is beta 2, it will be mu 4 by mu 2 square. So what is mu 4? We already derived it as b minus a whole power 4 by 80 by b minus a whole square by 12. So it will become b minus a square cancel. So 12, so it will become, once again, b minus a whole square by 80 into 12. So if we cancel all these things, we'll get approximately equals to 1.8. So what does it means? Beta 2 is less than 3. We are getting the only 1.8. So it means it is less than 3 value. So if it is less than 3 value, then we can conclude that uniform distribution follows Patty kurtosis. If it is less than 3, if the value of the kurtosis is less than 3, we can conclude it as it is following the Patty kurtosis. So this is about the central movements of the uniform distribution movements we are generating. So coming to the movement generating function. So coming to the movement generating functions, if x follows uniform distribution with the parameters of a comma b and moment generating functions f, it is defined as mf of t equals to expectations of ext. It can be written as integration minus infinity to infinity e power tx into f of x into dx. So what is f of x? F of x is the PDF of the probability density function of the uniform distribution. So what is f of x? In the previous one, you already told you need to remember two things, mean variance as well as the f of x. F of x is the 1 by b minus a. We are substituting the 1 by b minus a here. And we are taking out this 1 by b minus a outside. So it will become 1 by b minus a integration of a to b e power tx into dx. So for integrating this, we can conclude as 1 by b minus a. So tx by t into b a. So in the place of b, we need to substitute all the things. So first time we need to substitute the b value after e plus a also. So what it will becomes? So b 1 by b minus a e power bx by, because we are taking b first time and second a. So by t minus e of ax by t. So this is the required MGF. What is MGF? It means movement generating functions for the uniform distribution. These are the things you need to remember for the exam. This is very important topic. You need to be careful. So from this, you can do the exercise sums and the summary also and the model questions also. We will conclude this session actually by remembering, like recollecting all the formulas we already discussed. So in the rectangular distribution, we uh, we concluded that f of x is a probability density function. F of x is a probability density function, and we concluded that two conditions here. These are the very important conditions you need to memorize every time. So these are the two conditions. From coming to the distribution function, for next coming to the distribution function, we concluded that the formulas for so the formulas So for this, we concluded that a rectangular having the minus a and a intervals, then it will be 1 by 2a if the condition is the interval of the x is minus a to a. So coming to the movements of the things, movements of the uniform distribution. So mean value and the variance value, we can see. What is the mean value? We are concluding the mean value as mu1. Mu1 equals to b by a by 2. This is the mu1. So what is mu2 value? Mu2 dash value. So b square plus a square plus ab by 3. This is the mu2 value. And next coming to the mu3, mu4 and mu5 so on values you can derive from the same formula. You will get it as very easy. Coming to the central formulas, central movements. Uh, so central movements only mu2 value we can conclude it as variance also. Mu2 as a variance also. So mu2 as variance we are considering it. So mu2 will be variance will be a minus b whole square by 12. This is a variance formula. Coming to the central movements for the uniform distribution, we derived with the formulas, all the conditions, transformations we did for the easy calculations. So if you are having, if this is a formula for the central movements for the uniform distribution, if you are substituting the r values as 1, 3, 5 or odd, any odd numbers, then it will become equals to mu of r will be equals to the 0. Mu of r will be equals to the 0 if you are substituting any r value as odd number. Then coming to the even numbers, what will happen to the even numbers means if you are taking any even numbers for the mu 2 we are getting some value and mu 4 we are getting some value. So from that some values we can find out the skewness as well as the kurtosis also. So from the mu2 value, what is the mu2 value? It will be mu2 as b minus a whole square by 12. And mu4 value as b minus a whole power 4 80. So these are the values. From the using these values, you can find out the skewness as well as the kurtosis also. For beta 1 is equals to mu3 square by mu2 cube equals to 0. It definitely symmetric as well as for kurtosis. If the value is b2 value is less than 3, it follows the Platy kurtosis. Then coming to the moments generating functions. So moments generating functions, we are taking some conditions. It follows the uniform distribution and having the parameters. So if it is having the parameters, we are taking this point and from that we are deriving f of x and all the values we require. So the final moment generating formula will be, so this is the formula. What is the formula? So 1 by b minus a expectation of e power bx by t minus e power ax by t. So this is the formula for the moments generating function. So this is the and the summary and everything we can for normal distribution from tomorrow like in the next class I'll explain about the normal distribution. So if you have any doubts you can ask me in the comment section. Thank you.